Good morning, class. Today we will be focusing on calculus integration by substitution. Please like, comment, and subscribe. Please donate on the Cash App with the dollar sign up front, MLBFAN. Here we see a function that is an integral from 5 divided by 4 minus square root of x to the third power times 1 minus square root of x dx. So, we must know from college algebra that dealing with square roots, we need to know this property here. Base, sorry, root, and then base to the power. And it needs to be flipped to a fractional exponent as base to the power divides the root. So now a square root has a magic number or root index of 2. And then the power that is above x is technically a 1. So we want to flip that around as x to the 1/2 power, because this 2 here is the root index, the x is the base, and 1 is the power. So we can rewrite this integral as from 1 to 9 of 5 divided by 4 minus the x to the 1/2 power, all raised to the third power, times by 1 divided by x to the 1/2 dx. So now we need to let u equal 4 minus x to the 1/2. And du is equal to the derivative of 4 minus x to the 1/2. So it'll be negative, bring the power down. So negative 1/2 x to the 1/2 power minus 1 dx. And let's separate this off here. So du is going to equal negative 1/2 x to the negative 1/2 power dx. And then we divide both sides by negative 1/2 x to the negative 1/2. So now we can rewrite this function. Once we solve for dx, and dx is equal to du over negative 1/2 x to the negative 1/2 power. And then technically I can put a 1 in front of that du. And now I can rewrite this function as the square root from 1 to 9 of 5 over u to the third power here, multiplied by 1 over x to the 1/2 power times 1 over negative 1/2 x to the negative 1/2 du. Separate this off here. And now we notice a situation where we could use product rule from college algebra, where if you have the same base, so product rule, so when you have the same base, like x to the 1/2 times x to the negative 1/2 is equal to x to the 1/2 plus negative 1/2, and which is equal to x to the 0 power, and which is equal to 1. So this can be rewritten as the integral from 1 to 9 of 5 over u to the 3rd power times 1 over x to the 1/2 power then times, actually, since we canceled that out there, this can technically be written as the integral from 1 to 9 of 5 over u to the 3rd times 1 times 1 over negative 1/2 times 1, because we utilized the product rule there. And then du. And the reason why x to the 1/2 times x to the negative 1/2 goes to 1, because of product rule. When you have the same base, you add the exponents, and we get x to the 0 power, in which is equal to 1. And so now this integral can be rewritten as from the integral from 1 to 9 of 5 divided by u to the 3rd times 1 divided by negative 1/2 times 1 du. And so now we need to move on to the next part of the problem. So the integral from 1 to 9 of 5 divided by u to the 3rd, and we simplify that as 1 times 1 is 1 divided by negative 1/2 times 1 is negative 1/2 du. Okay, so we have that so far. And so we can use 5 divided by negative 1/2. Let's simplify that right away here. So 5 divided by negative 1/2 can be rewritten as 5 divided by negative 1/2. And so 5 divided by negative 1/2, and we want to multiply by the reciprocal, so 5 times negative 2 over 1 equals negative 10. And so 5 divided by negative 1/2 can be rewritten as negative 10. So the integral from 1 to 9 of negative 10 divided by u to the 3rd du. And then I could utilize laws of negative exponents here. When it's the power is positive in the denominator, if I bring u to the third to the numerator, the exponent will turn negative. So the integral from 1 to 9 of negative 10 times u to the negative 3 du. So now we could integrate. And it may be easier to integrate by pulling that factor of negative 10 to the front of the integral. So let's do that. And 10 times the integral from 1 to 9 of u to the negative third du. And when we integrate, it's going to be negative 10 times u to the negative 3 plus 1 divided by negative 3 plus 1 from 1 to 9. And so this will be negative 10 times u to the negative second over negative 2 from 1 to 9. Actually, 1 to 9 here. And so negative 10 divided by negative 2 is going to be positive 5 u to the negative second from 1 to 9. And we had a substitution earlier when we stated let u equals 4 minus x to the 1/2, and we need to replace u with that. So it's going to be 5 times 4 minus x to the 1/2 to the negative second from 1 to 9. Okay. So 5 times 4 minus x to the negative 1, x to the 1/2, I should say here, and then to the negative second from 1 to 9. Now I can flip this fractional exponent back to the square root of x. So x to the 1/2 here, top part is the power, the denominator is the root, and this is the base. And so I can flip back and say root base to the power. So 2 for the root, base, would be x, and then to the power of 1. And the square root is the only root where the index can fall off there, and so we'll just write x1 as x. Okay, and so 5 times 4 minus the square root of x from 1 to 9. So now we can begin our direct substitution here. And our a value of the integral is 1 and 9 is b. So we plug our b in first and then our a in first, and then do the calculation for b substitution minus the a substitution. So 5 times 4 minus the square root of 9. And then don't forget here, there's a power of negative second here for the to the negative second minus 5 times 4 minus square root of 1 to the negative second power as well. As we have to go back here, and then the u here is being raised to the negative second power, and earlier we had 4 minus x to the 1/2 as our u. So now let's go to the next page here. So 5 times 4 minus the square root of 9 to the negative second power minus 5 times 4 minus square root of 1 to the negative second power. So now we can begin to simplify. So it's going to be 5 minus the square root of 9, which is 3. So 4 minus 3 to the negative second power minus 5 times 4 minus 1, in which is the square root of 1 to the negative second power. So 5 times 1 to the negative second power minus 5 times 3 to the negative second power. Right? So now dealing with laws of negative exponents. So we want to do 5 times 1 over, and since it was negative in the numerator, so it's going to be a positive exponent in the denominator, so 1 to the second power minus 5 times 1 over 3 squared. So that will be 5 times 1 over 1 minus 5 times 1 over 9, because 3 squared is 9. So in which this will be 5 times 1 divided by 1 is 5 over 1, because we want to make 5 a fraction. So 5 times 1 divided by 1 times 1 is 5 divided by 1. And make this 5 a fraction as well. So 5 times 1, in which is 5. And then 1 times 9 is 9. So now we need to simplify 5 divided by 1 minus 5 divided by 9. So we want to find a common denominator. So the least common denominator is 9. So I only need to alter the first fraction. So I want to multiply by 9 over 9 times 5 over 1 minus 5 over 9, and which is equal to 45 over 9 minus 5 over 9, and which is equal to 40 over 9. This is our final answer for the solution for the definite integral. This is how we calculate this particular integral by substitution. Please text 559-744-3169 for math help, and please donate on the Cash App. With the $ up front, MLB FAN. So please text 559-744-3169 for math help. Please donate on the Cash App with the $ up front, MLB FAN. I tutor for several different levels of mathematics. Please text me which class and mathematics that you need help with, and let's get down to business and learn math together. Thank you so much.